Have you ever been crawling along in bumper-to-bumper traffic, looked down at your phone, and just wondered, how did Google Maps know? How did Waze know about this mess before I could even see the brake lights? You know, it really does feel like magic, but it's not. It's actually a really fascinating story about data, about community, and some seriously clever tech. So today, let's pull back the curtain and see how it all really works.
So, let's just ask it straight up. How is it possible? How does this little slab of glass and metal in your pocket have this godlike bird's-eye view of every single road all happening in real time? Well, the answer isn't some secret government satellite or a single piece of crazy high-tech. Actually, the secret ingredient is all of us.
And this is the perfect illustration of how it works. Back in 2020, an artist decided to put this system to the test. He grabbed 99 smartphones, turned on their navigation, and put them all in a little red wagon. Then he just slowly walked down a completely empty street. And guess what happened on Google Maps? That street turned deep, angry red. A massive traffic jam that didn't exist. He totally tricked the system. But in doing so, he showed us exactly how the whole thing works.
So here's the secret sauce. It's all about crowdsourcing. Your phone and millions of others are basically anonymous little sensors out there on the road. They're constantly reporting their location. And, this is the key part, their speed. So when the system sees thousands of phones on the freeway that were going 65 suddenly drop to 15, well, it doesn't take a genius to figure out there's a traffic jam. And on top of that, you have apps like Waze, which really built their whole empire on users manually tapping their screens to report things like accidents or debris on the road.
It sounds like a perfect system, right? A brilliant, powerful idea that helps everyone. But there's a fundamental flaw, a really big one, hiding in plain sight. A danger that comes with every single one of those taps.
And this quote from a 2019 research paper out of Carnegie Mellon University, it nails the problem perfectly. Can we have the benefits of Waze without user distraction? I mean, the very act of trying to help make the roads safer is itself creating a whole new danger. So the real question becomes, is there a way to get all this incredibly valuable info without putting drivers at risk?
And that's really the heart of the issue. We're asking a driver, someone who should be 100% focused on driving, to look away from the road, look down at their phone, navigate a menu, and tap a button to report a pothole. It's a paradox, isn't it? We're relying on distracted driving to report the dangers on our roads. It's a recipe for disaster.
Okay, but this is where that same research from Carnegie Mellon gets really exciting, because they didn't just point out the problem. They developed a solution, an automated system that lets the car itself see and report hazards. No tapping, no swiping, no human interaction needed at all.
The project is called LiveMap, and it's designed to give us all the incredible benefits of crowdsourced road data, but with absolutely none of the driver distraction. It's a completely new way of thinking about how we see the road.
And this right here, this shows you the difference in the starkest terms possible. On the left, you've got the old way, a driver dangerously fumbling with their phone, eyes off the road. And on the right, you have the new way, a computer just seeing a pothole. It automatically identifies it from a camera feed. The goal is to make this whole process completely invisible and effortless for the person behind the wheel.
Okay, so how in the world do you teach a car to see a pothole? Well, it's a combination of a few really amazing technologies that are total game changers. Let's pop the hood and take a quick look at how the LiveMap system actually works.
Now, this diagram might look a little complicated, but the core idea is actually pretty simple. See that vehicle cloudlet? Think of that as a mini computer inside the car. It's doing the first round of analysis. When it spots something that looks like a hazard, it sends a tiny little alert to a nearby server, a zone cloudlet, which gathers up all these reports. That server then updates the master map, which can instantly warn other cars that are headed that way.
The first piece of this puzzle is something called computer vision. And honestly, you can think of it like teaching a small child. You show the computer thousands and thousands of pictures of potholes, of traffic cones, of debris, and eventually it learns to recognize them all on its own in a live video from a car's camera. It's literally artificial intelligence for sight.
The second key ingredient is edge computing, and this is just brilliant. Instead of trying to stream hours and hours of video from every car up to some giant data center, which would use a crazy amount of data and money, the idea is to put a powerful little computer right there at the edge of the network, right inside the car itself. This mini supercomputer analyzes the video in real time and only sends a tiny alert when it actually sees something important.
So the researchers actually tested two different ways of doing this. First, you have the big vehicle cloudlet. Think of this as the super-powered, high-cost option. It does all the heavy lifting right there in the car for maximum speed and accuracy. Then you have the small vehicle cloudlet, which is more like a high-end smartphone. It's way cheaper, but not as powerful, so its main job is to just find interesting bits of video and send those to a server for the final analysis. It's your classic trade-off, power versus cost.
And check this out. This is what that big vehicle cloudlet actually looks like. I mean, this is a serious piece of hardware. It's a rugged, liquid-cooled server packed with powerful GPUs, and it's built to handle all the bumps and temperature swings of being inside a car. This thing is the brains of the whole operation.
Okay, so this is a really cool research project. But what does it actually mean for our future, for our daily commutes? Well, the real-world results they got are pretty staggering.
Let's just start with this one number, 95%. By using that edge computing idea, by analyzing the video inside the car, the system cuts down the amount of data it has to send over a cell network by an average of 95%. That is not a small improvement. That's a total game changer that makes a system like this actually affordable and possible to roll out on a massive scale.
And here you can see what the final result looks like. This is the kind of map a city's Department of Transportation might see. Hazards just pop up on the map in real time, and they can even click on one to pull up the actual photo for verification before sending a repair crew out. How cool is that? And here's the proof in the pudding. These are actual detections from the live map system out on real roads. You can see it correctly identifying and drawing a box around multiple potholes in different kinds of light with a really high degree of confidence. The bottom line is, it actually works.
And what's really exciting is that this tech is not just about potholes, not even close. Because it's a flexible AI platform, you can train it to spot almost anything. Think about it. Traffic cones that signal a lane closure, dangerous debris on the highway, construction equipment, road signs. You could even train it to spot the visual evidence of a recent accident. The possibilities here are just huge. Which really brings us to our final thought for the day. We started this journey with a system where we, the humans, had to tell the map what was happening on the road. Now, we are entering a world where our cars can see and report on the state of our roads all by themselves, automatically. So, if our cars can see potholes today, what else should we be teaching them to look for tomorrow? What other big problems could a whole city full of observant, intelligent vehicles solve for us? The road ahead looks very, very interesting.